Assalamu alaikum everyone. My name is Muhammad Ehsan Al Kabir. Today I'm gonna discuss about semiconductor and electronics. What we learned about semiconductor. A semiconductor is a material whose electrical conductivity is between that of a conductor like copper and an insulator like glass. The most common semiconductor material is silicon, and another important one is germanium. So, what we can understand by a semiconductor? First of all, if we look at this drawing, it is a picture of an conductor element. It has an covalent band and a valence band, and the remaining part in the middle between the covalent and the valence band is the power band. So what can we understand from covalent band and the valence band? So the valence band means the remaining the last orbit of an atom. The remaining last orbit, what number of electrons we've got, is called the valence band. Likewise, we can say that it is an atom, it is germanium. So we can see that at germanium's last orbit there is remaining 4 electrons. So the valence band of germanium is 4 electrons. Then we will move to the insulator part. The insulator part is means it will show a difference between the covalent and the valence band. It will not conduct electricity, but this conductor part will conduct electricity. Then we can see that the semiconductor part will conduct electricity in a very special way. Then the power band difference between the covalent and the valence band should be less than 1.1 electron volt. Then we will come to the what can these drawings are meaning by covalent and the valence band. If you see to the germanium and the arsenic atomic numbers, so they have arsenic have 5 electrons at the last orbit and germanium has 4 electrons at the last orbit. So the remaining 5 electrons of arsenic and the remaining 4 electrons of germanium are the we can call them as the valence band. When the germanium and arsenic atom will create a bond between them, the extra 1 electron remaining in arsenic will create a bond with germanium. Likewise, if we take this electron which will make a bond with the remaining with the difference of germanium and arsenic atoms, 1 electron at the last orbit, if we say that this electron make a this freedom electron will make a bonding, then this freedom electron will work as a covalent band. So this freedom electron will work as a covalent band, and after it will act as a covalent band, we can see that the arsenic's remaining free electron will work as a pentavalent dopant. And here is the diagram. And then we will move to the types of semiconductors. Semiconductors are two types. There are intrinsic semiconductors, are pure semiconductors with no added impurities. Its conductivity is low because of small numbers of electrons available to conduct. Then we also have there is two types of semiconductors, and another one is extrinsic semiconductors. This process is called doping. We have to add impurities at that part. After doping, the semiconductor becomes an extrinsic semiconductor. Extrinsic semiconductors are two type, n type and p type. uh, n type semiconductors doped with pentavalent atoms such as phosphorus, extra electrons become majority carriers. Then p-type semiconductors doped with trivalent atoms such as boron holds majority carriers. Um, then finally, I have to clear a thing that semiconductor is just an material which is used in diode transistors uh, to rectify the current. We know that resistors can rectify currents, so diodes are work to rectify currents, and transistors are work to amplify and switch currents. So it is very important to electronic items to use of semiconductor, diode and transistors. Without semiconductor, diodes and transistors, uh, the electronic uh, world will uh, have no nothing. It is semiconductors, diodes and transistors are used in computers, smartphones, LED bulbs, even the internet. And thank you for